So today topic is prime number. We will be discuss the most optimized prime number algorithm. Okay, so you know the prime number will be solving big of n, big of root n. Today I will be solving this algorithm using the big of 2 root n. Okay, this is the most optimized algorithm and it will be skip lot of iteration. We are never going to be iterate from the last of the element. Okay, so before solving this problem, I will tell you what is prime number. Prime number who has the two factors like 1 and its number itself. Okay, like I am giving example like n equal to, let's say, 2. So 2 is a only even prime number. Okay, rest all the even numbers have the composite numbers. What is composite number? Who has the more than 2 factors. So here in 2 it's a prime number because it's divisible by the 1 and it's 2 itself. Like another number is 11, it's divisible by 1 and 11. Okay, these are the prime numbers. Okay, so we are going to the now I am starting the code. Okay, so after a dry run I will be going to the soft run. Don't worry about that, I will be write all the program complete in Java. Now I am explaining code in this board in pseudo each prime is the method name and int n the input. Then firstly, if the number is equal to n, if the input number is 1, then return false because 1 is not a prime number. Okay, so if write the first condition n equal to 1, then return false. Okay, then if n equal to 2 or n equal to 3, it's little bit confusing, but we will be understood it after explaining after doing the dry run. Okay, so now let's know how the code, how the format, like how the flow of the code. Okay, n equal to 2 and n equal to 3, then we will be return true because 2 is the prime number and 3 is the prime number, both are the prime number, so we return the true. Then we write another condition like if n modulo 2 equal to 0 or n modulo 3 equal to 0, then return false. Okay, if the number like 4 is divisible by the 2, then also it return false. If the number 9 divisible by the 3, then also it return false. Okay, then we write another condition, we start a loop like for int I equal to 5. We're starting I from the 5, not from the 2. Then I into I, like it calculate the root over less than equal to n, then I equal to I plus 6. Okay, so here we are starting the loop from the I5 and we are traversing to the last of the element, root over of the element. Okay, then we are skipping the iteration by adding the plus 6. I am giving the example. Okay, don't worry. Then we write another condition like if n modulo I equal to 0 or n modulo I plus 2 mean 7, I is 5, I plus 2 is 7, equal to 0, then return false. Then return false, else return true. So let's take a number. Okay, first try to understand the code. Okay, here we are starting the number condition from the n equal to 1. Like if a number itself is 1, n equal to 1, then it's don't enter the rest of the code, not will be executed, it's not going to be execute. Okay, so it's left the code, it's return the value from here, like if n equal to 1, it is the best case condition. Okay, if n equal to 2 or n equal to 3, if the number is n equal to 2, then it will be written from here, the rest of the code is not going to be executed. Okay, if n equal to 3, then also it will be written from here. If the n modulo 2 equal to 0 and n modulo 3 equal to 0, then also it return false. Like if n equal to, let's say, 12, okay, its modulo 2 equal to 0, so it satisfies the condition, it never going to iterate the whole loop. Okay, if the number is basically 21, then also it will be written from the here, like it's a not prime number. Okay, so it's the not prime number, so it will be written false here. Then start, we will take an example. Okay, we should write a number from 1 to 21. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21. Okay, after this, so we will be start our loop. We'll check the condition, like with up to 21, like which number are the prime and which number are not prime. Okay, in the range we will be check the prime number between the range from 1 to n. Okay, so here the code, first we check n equal to 1, return false, then 1 will be completely out of the loop. Okay, it's not a prime number. If n equal to 2 and 3, then it's not prime number, it's a prime number. So we will have this number is true. Okay, then if n modulo 2 equal to 0 and n modulo 3 equal to 0, then we check this condition. Okay, so in here 4 divisible by 2, condition is n modulo 2 equal to 0 or modulo 3 equal to 0. Then here we check the conditions, like 4 is divisible by 2. Okay, 5 is not divisible by 2, 5 is not divisible by 3, 6 is divisible by both 2 and 3, 7 is not divisible, 8 is divisible, 10 is divisible. Okay, 12 is divisible, 14 is divisible. Okay, 16 is divisible, 18 is divisible by the 2, and 20 is divisible by the 2. Then check by the 3. By 3 6 will be divisible. Okay, 9 will be divisible, then 12 will be divisible. Okay, then 18 will be divisible, 21 will be divisible. Okay, so after this condition we will be eliminate these numbers. So rest, now we have only these numbers, like the numbers are 11, 13, 17, 15, 17, 19, then 2 and 3. Okay, so we are not in here, we are not entering into this condition, like for I equal to 5, then I into I less than equal to n, then I equal to I plus 6. We are not entering to this condition. Okay, we are not iterating. Okay, here we reduce the time complexity, right? So if we take another number, like will we check from n equal to 1031. Okay, So it's a prime number or not, we have to be checked. For that, so it's a prime number or not, it's a prime number. Okay, how we check? So here we will be start the loop. Okay, is it divisible by, is it 1, n equal to 1? No. Is n equal to 2 or n equal to 3? No. Then is n modulo 2 equal to 0 or n modulo 3 equal to 0? No. Now we start the loop, like I equal to 5, I less than equal to I into I less than equal to n, then I equal to I plus 6. Okay, then we check the condition, like if n modulo I equal to 0 or n modulo I plus 2 bracket, don't forget to add the bracket. Okay, equal to 0, then return false. So we check for the 1031 from the starting from the loop. Okay, for the 1031 first we will be start from the I, 1031 divided by 5. Okay, is it equal to 0? No. Then is it divisible by the 7? 1031 is divisible by the 7? No, it's not divisible. Then we will be increment I plus 6, like 5 plus 6 equal to 11. Now its condition is I is 11, 11 into 11, like 1 to 1 less than 1031. Okay, condition. Then we will be check like whether it's divisible by or not divisible by the 11, like 1031 divisible by 11? No. Okay, 1031 divisible by 2, like 13? No. Okay, then we will be increment it, like I, now I become I plus 6, 11 plus 6 equal to 17. So I now equal to 17, then 17 into 17, what is 289, like 17 into 17 less than equal to 1031, like it's 289 less than equal to the condition satisfied. Then we will be check, like 17 is 1031 is divisible by 17? No, it's not divisible. Then 1031 divisible by 19? No. Now why 19? Plus 2, na? We are adding each and every time we are adding 2, like while checking the conditions each and every time we are adding 2 here, so we are incrementing into 2. No. Then 17 will be incremented, 17 plus 6. So what is 17 plus 6? It's 23. Okay, so now I become 23, then 23 into 23, then 23 into 23 less than 1031, 23, 529. Okay, so 529 is less than anything. Then we will be check using 1031 modulo 23, is it divisible by, again no. Then 1031 23 plus 2 25 divisible? No, it's not divisible. Then we will again increment, like I is 23 this time, 23 plus 6, 29. I is 29 this time, then I equal to 29, then 29 into 29 into 29 less than 1031 less than equal to 1031. Condition satisfied. Now check 1031 modulo 29 is divisible by 0. No. Then 1031 modulo 31 divisible by 0. No, it's not divisible. Then we will be increment 6, 29 plus 6, 35. Now I equal to 35. Then we will be double it, 35 into 35, 35 into 35 less than 1031. Now it's 35 and 1225. Now loop will be terminated because it's not satisfying the condition. The loop will terminate. Like where we run up to the loop, where from 35. Look, where is 35, where is the 1035. Okay, we will be pause the loop in here. So if the number, any factor will be not come to divisible by the some number, then it will be loop will be terminated, right? So now we will be return false, like it's not a, sorry, it will be return true here. It's not a, it's a prime number, it's a prime number. Look how many iteration we will be skip if we will be do it in that method, right? We will be do it in the previous like n square method or root over of n method. Then we have to in n square in n square we have to traverse the full loop, like from 2 to 1031. In n by 2 we have to traverse from here to half of the number, right? Like 1031 by 2, half of the number. But here we will be pause the loop on 35. On 35 it's 2 to, so now here the time complexity is big of 2 to the power root 10, big of 2 to the power root 10. So this is the most optimized algorithm for the prime number. Okay, now I will be try run it. Let's see. Sorry, I will be running it in the compiler. Let's see. So now we will be run this prime number code in the compiler. Okay, let's see step by step. This is the online compiler. Here we write the code. Like initially we declare the we will be create a method like static boolean is prime. Then we pass a variable like int n, which we will write our first condition. If n equal to 1, then what will we do? Return false, right? Then we write the second condition. If n equal to 2 or n equal to 3, then will be return true. This case will be return true because 2 and 3 are the prime number. If n modulo 2 equal to 0 or n modulo 3 equal to 0, then will be return false. This condition also return false because the even numbers are 2 divisible by the 2 and the 9 and 12, these are the divisible by the 3, then it will be return false directly from here. If any number like even or odd, it will be, if that number divisible by the 2 or 3, it will be written from here, not going into the loop. Then we will start the loop for int I equal to 5, then I into I, like here we getting the root over, okay, less than equal to n, then I plus equal to 6. We will be shift the I from we will be incrementing each time 6. I will be 6. Like if initially it's 5, then it's 11, then it's 17, then it's 23, so on. So here we check the condition. If n modulo if n modulo I equal to 0, or n modulo I plus 2 incrementing into the 7, precedence most important, so we add the, don't forget to add the bracket, equal to 0, equal to 0, then also return false, then also return false, else return else return true. We forget to add the bracket here and one here. Okay, now we call the statement, like call the method as system dot out dot print parent println, like number is call the method is prime and number is 5. Let's see it's working or not. Yeah, it's working. It's true, mean it's a prime number. If we giving 11, then it's a prime number. If we giving 12, then it's a false, it's not a prime number. Okay, if we giving 1 0 2 3, it's not a prime number. If we give 1 0 3 1, it's true, it's a prime number. Now we'll be see how to check these prime numbers in between the range. Okay, also check the prime number in between range. There is only one logic, that's write the logic, like int I equal to, let's say I'm starting from the 34 and I less than 1000. Okay, I plus, then write a if condition, if is prime of pass the parameter I, then system dot out dot println at I plus is prime. Dot. Let's check is it working or not. Oh, forget the semicolon, there is a silly mistake. Let's check. Yeah, it will print all the number, right? From 37 is a prime number, 41 is a prime, all the prime number will be printed here. Okay, so this is the range, like we check the range from 34 to 1000. Okay, here is the condition. If we debug it, let's check how it will be work. Okay, first add here a breakpoint. Now start debugging. Okay, start. Now its I is 34, right? Like check here n equal to 34, then continue. First it check is it n, no, then go to the next condition, like check if n equal to 2 or n equal to 3, no, then it will be skip into the next step. Here it will be check n modulo 2 equal to 0 or n modulo 3 equal to 0. Okay, continue. Yes, here it's pass, then it will be increment, like 35, after 35 it comes to 36, sorry 34, after it will become 35, right? Then we'll start iteration, then it's check whether it's 2 or 3, no, then check, then whether it's divisible by 2 or 3, check, no, it's not divisible by 2. Now it's going into the loop, like here it's I equal to, right now I equal to 5, then n modulo I equal to 0, like it's divisible by I right now, or I plus 2 means 7. Then check, yes, it's divisible by I, like I start, look here, I equal to 5, then it's divisible by the I5, then skip the number, increment the number into 36. Now check 2, no, same. So this one, okay, do it by yourself, debug it step by step, and you will be know. So what is the time complexity? Big of 2 root over of n. Let me summarize this. First we check the n equal to is n equal to 1, then in best case it will be written from the year. Okay, then we check n equal to 2 or n equal to 3, then it is a true, like it's a prime number. Okay, then we check n modulo 2, like, oh, if there is even number like 14, 16, 18, okay, these numbers will divisible from here. If the number is like 9, 12, 21, this number will be divisible by the 3, then it will be return the statement from here. We are not going into the loop and incrementing each number, we are not checking each number step by step. Okay, then the loop, if the number is like 5, 15, not 5, 15, 35, 55, this number will be checked here. Okay, then we incrementing each time I plus 2, like 5 plus 7, we are checking both of the number, if it is divisible by the 5 or divisible by the 7, then so we return false, else we will be return the true. So here we pass the range. Okay, so this is all about the program.